In our lab, we mostly focused on bearings, rolling element bearings. For them to function really well at any operating condition, we need to have some sort of lubricant that separates any components that are in close proximity to each other. We observed that at high speeds, the lubricant would never come into the contact with the surface and would simply levitate or would fall off. That got us to explore this particular phenomena, which is the aerodynamic Leidenfrost effect.
The thermal Leidenfrost effect can be seen on heated pans, where if you drop a water droplet on the hot surface, the droplet itself hovers on a vapor cushion. On the other hand, the aerodynamic Leidenfrost effect, once a certain threshold is reached, which is the Leidenfrost velocity, the droplet is supported by an air cushion. And so that's the aerodynamic Leidenfrost effect.
What we see is that the lubricant droplet is levitating on an air cushion on this outer raceway surface. We really want the lubricant to adhere well to the surface, but now at this speed what we are seeing is that the lubricant is not adhering to the surface, rather it's simply levitating over the surface. Whenever that happens, we run into the risk of starvation and wear, heat generation, friction, and ultimately early failures. Moving forward, this can be extended to the real bearing configurations. There we can explore different lubricant delivery methods and see which one is the most effective to mitigate this aerodynamic Leidenfrost effect at high speeds. As a mechanical engineer myself, I like to get my hands dirty when I'm working, right? So it really excites me when I get to see the things that we study in our day-to-day lives in action.